I work for the rigging side of M Yachts, where we work on pretty much anything from the mast down to the deck, including chain plates and a little bit below the waterline. And we are here to, help create the best boats that we can. I'm actually going to pause screen sharing for a second because I have some visual things that I'm going to show you guys. I'm going to pretty much go through an inspection the way I would if I was actually on your boat starting to look at it. So when I start on a boat, the first thing I look for are your halyards. And these are things that often end up a little bit overlooked and neglected for long periods of time. So first, this is a relatively new halyard. It's a half halyard with a Dyneema core that we pulled off of a boat last week. Please ignore my dog, I'm sorry. And it, as you can see, has a lot of chafe damage to it. It's gone right through the cover and into the core. And I don't know if you can see, but on this core, it's actually starting to get fuzzy here. And that's the Dyneema starting to break down. So what we see on a lot of boats is they have halyards that look kind of like this. They get kind of dry, they're maybe a little mildewy. This one in particular has another good chafe section on it. And hopefully what you can see as I start flaking this, we have some little bits of dust coming off. And as they get dry and mildewy, they start losing pieces of fiber. As you can see here, I have now a lovely pile of fiber, and that is the line degrading and breaking down. So as it starts to get fuzzy, all these strands are breaking. So you may not think that it looks like chafe, but it actually is. And it's your lines breaking down and they need to be replaced. Another thing I look at are your snap shackles. This is a really fun example. This is one that has been on a rail for a while, and you can see how little metal's left on the bottom just from it wearing on itself. Where we often see snap shackles fail is up here at the pin and here on the front of it at the bottom where the lever pin pops through. And this is from being in use, and we get metal fatigue, which we will go over a little bit later. So back to screen sharing. The next thing that I look at are your blocks. So this one, you can see that the shackle has come loose on. You can see a couple threads in here. And what would happen with this shackle, if you had a flagging line on it, is that pin could continue to become unspun and you would lose that shackle. The next thing I look at is block alignment. So you can see here on this bright red halyard with the yellow fleck that the halyard comes down into the block, into the nice curvature, and exits at the same nice curvature at the bottom. Whereas this white one with the red fleck comes down and sits on the edge of the block and is wearing on the cheek. And you can see it does the same thing at the bottom of the block. What happens when that happens is this. These were two blocks that sat against each other for a gang. So one had a nice lead angle, the other one did not. And after the strain of being on there and rubbing in the wrong direction, it completely blew up. So when I start your rig inspection, I start looking at your blocks and your lines, because these are the things that get used and abused the most. And these are the things that I need to trust to get me to the top of your rig. So now we've gotten to the top of your rig. One of the big problems we see up there is often a halyard wrap. This particular one shows a bird cage. That's where a halyard has wrapped around your stay and twisted it in the wrong direction. The problem with a bird cage is now we're putting all the load on the center strands, and this one even has a broken outer strand. And as those strands of wire start to break, they don't have the same structural integrity. So now you're down to half the load of your wire, and they'll start point loading after that and continue to break. So here is how you avoid a halyard wrap. You need a halyard retainer. So this first picture shows an angle separation, providing a halyard wrap. It's a little dramatized and the angle's not great, but you can see that there's about a 15-degree of separation between the halyard and the stay. The second one is a much better example where the green represents a halyard restrainer that creates a nice deep angle, preventing the halyard from wrapping around the stay. And this third photo shows a puck attached to the stay, which keeps the halyard away from it and encourages it to stay on one side. You often see a puck with another style, and I'll show you that in a second. The next way to prevent a halyard wrap is to get a pennant attached to your sail. We often use a piece of Dyneema strap, and this raises the halyard swivel a little bit higher so that the halyard can't wrap around the stay because it's not long enough. So here is an in-life practical example of how a halyard restrainer works. You can see the green halyard exits the masthead up here, comes through the restrainer, and then comes over to the top of the swivel where it has a nice angle and is prevented from wrapping around. The red halyard crossing it is a separate halyard used as a safety line in this particular example. This is an example of a pro-furl furler with a halyard puck, and it actually has a plate on the top of the swivel which engages with the puck. That has the halyard attached at the top of this plate, engaging with the puck so that it can no longer turn and is forced to stay straight. As we're at the top of your rig, we're looking around. This is a particular example of a foil that has dropped down. This is your foil here, and this is the inner bearing of the foil. This is something we see happen quite a lot. Either the foil will drop or the bearing will drop inside of the foil. The problem with this is that the top of that foil is not a nice round shape. So as that foil is no longer has the bearing in it, it's going to start rubbing against your wire, creating a chafe point on your wire. Coming down the rig a little bit, we're looking at our spreaders. We generally look at the pins in the spreaders, make sure the spreaders are tight here. And what you can see in this particular example is we have a running backstay made out of wire that has sat here and started to chafe on the leading edge of the spreader. This doesn't cause any particular damage. It's not pretty and it can start creating a sharp edge. So we do want to avoid it, and we'd avoid that by changing this runner to a piece of Dyneema. We'd go up, we'd file the edge of the spreader to make sure it's no longer rough. You don't want your sail when you're downwind to be leaning against that spreader and chafing. So although at this point, this damage is nothing to be worried about, it is something that you don't want to continue to eat into the spreader. All right. Pins. This is something we see way too much of. So up here at the top of this rig, we have three things with mismatched pins. We have about a 1/2 inch pin going through the head of the mast for the backstay. We then have a 5/8 toggle going over the 1/2 inch pin. And then we have a 1/2 inch pin going through the backstay toggle. You can see that head just barely holds on that side. Oops, back one. And then you can see in on that eye that it is also sized for 5/8, but only has a 1/2 inch pin. So this is all very sloppy. What happens when this is loaded up is it creates point loading. So instead of filling that nice whole circle, it point loads on one starts and starts pulling through the circle, which will then create metal fatigue and eventually potentially failure. This one, you can kind of see the gap on the bottom of that fork. We also see something here that we hate seeing on rigs, especially aloft. This is called a ring ding or a cotter ring or a split ring. And what happens is you can see it has a nice flat piece in the middle of it. And if a halyard were to run up past that flat piece in the middle, it could very easily snag. I can very much so picture a spinnaker being hoisted on a spinnaker halyard, that halyard running right up into that ring and ripping that ring right out of that pin on the way up. But mismatched pins are what we're looking at. So you can see here that we have a cotter pin that's nice and splayed, but a pin that is much too small for the pin coming out. In some cases, having a pin smaller than the hole in the mast is avoidable. If it is unavoidable, what we do is we put a bushing in there to fill that space to make it the right size. All right, metal fatigue. This is a fun one. We see a lot of this. So this is down at the tangs. You can probably see, I hope that it's clear enough, that there is a small crack at the bottom edge of that tang where it's been splayed open and started working in. This tang would be called a failure, and we would remove it from the boat. If that crack continues, the whole thing can rip out. Metal fatigue happens for a lot of reasons. This is a beautiful example of turnbuckles with no toggles. These have forks on the end, which allow articulation right to left, but not fore and aft. If you've ever watched your rigging go loose on one side, that you see that it does little circles, and instead of being able to go fore and aft the way you want and do its little circles, you'll see that it starts to create fatigue. At the end of that turnbuckle is a threaded stud, and that stud has wire coming out of it. So if that turnbuckle can't move in the directions it wants to with the articulation, it's going to point load at the end of that wire. The same thing happens in furlers. You'll see that there's no toggle on the back of this. Furlers have a huge problem with this because a jib flogs and it needs to go fore and aft when it flogs instead of just side to side. So it's going to, again, point load fore and aft. It's going to create friction on the end of the wires, and you're going to see something like this. So it'll start with just one strand cracking, and then as more and more pressure is put onto it because it's losing strength every time a strand breaks, the next one down the line is going to continue to break, and it's just going to keep spiraling around. So that's what metal fatigue happens with the point loading of not having toggles and articulation in the right spots. All right, back on the rig, we are looking at all of the swages. So this one shows the start of crevice corrosion. Now it might look like a little bit of surface rust, but you can see that there are a couple divots which are starting to get deeper that are starting to look like crevice corrosion. So you can see in this one that those divots have actually started forming crack lines. And that happens from the inside out generally. This is a picture of a swage stud that has been cut open. And you can see that there are small gaps where the wire is, and where those gaps are, salt and moisture can get in and get trapped and start working their way out. So you'll see this is a nice, pretty cleaned up piece of stainless stud that has had crevice corrosion come in and split it open. This is a complete failure. The wire could end up pulling out from this, and if it was your forestay, your rig could come down. All right. So we talked about ring dings and cotter rings earlier. This is a cotter pin that is not properly bent. You can see it started to pull out. It's not open the way it should. If this pin continues to work its way out or gets snagged on something and pulls out, it could make your boom come off. If you're flogging or jumping, that pin can work its way loose and the boom could come off. We see this a lot in forestays. It's often a cause of demasting, is losing the forestay pin at the top or the bottom because it got snagged on something, ripped out, and the pin has worked its way loose as for sailing, and you have some flogging. So we've looked around on the deck, notice what's wrong. We go down below and we are starting to look at chain plates. This is a picture of wood covering a chain plate. When it gets covered, you can kind of see that this one's been leaking. You can see some discoloration on the wood. This shows that the chain plate has started to break down, that there's rust. This next photo shows where the water has been seeping in through the chain plate. You can see the rust trails and the water lines running down. I'm sure the backside of this chain plate is completely rusted out. Where a chain plate normally fails is in between the exposed area below, where it still has access to air, and the deck, where it is trapped in the moisture with no air. When stainless doesn't receive air, it starts to crack open, get porous, and starts to look like this. That's why generally that first piece that's through the deck is where the chain plate will rip in half and break open and remove itself from your rig. All right, so we looked at the chain plates. Now we're going to look at the mast step. This is one that we cut off of a rig. You can see that it's had a lot of corrosion and electrolysis eat its way up. This is about 1.5 inches up on the mast step. This is caused from having a grounding wire that's not grounded properly. It could be having a stainless mast step with aluminum sitting on it and nothing isolating it. It can have to do with bilge water or some other stray current. A lot of things cause electrolysis and corrosion, and it will eat away at your mast. If this continued, the mast would start sitting crooked in the boat. We see a lot of corrosion on things where you have pieces of stainless. You'll see in this photo that there's a stainless steel rivet into an aluminum bang with nothing separating them, and it has started to corrode. This is a great example. This is a foot block. It's a beautiful stainless plate with an aluminum block and stainless screws going through it. So we're having stainless touching aluminum in a salt and water environment. And you can see that the corrosion has actually started to break it down. And in this photo, you can see it removed, and all of this white on the bottom is corrosion. So in order to fix this, if you were to reinstall a new piece, you would have to clean all the corrosion off of that piece of stainless. You would then have to put a barrier down. We use a type of tape called Chrissy's tape, which is a lovely barrier tape. And then where the fasteners go through, so we have stainless touching aluminum, touching stainless, we'd want to isolate it with either Tef gel or Loctite or something along those lines in order to keep it separated and from actually making contact with the aluminum. So now we're going to start looking around deck. We're going to look at the lifelines. This is an example of a coated wire lifeline. And what happens with wire coated is that coating starts to shrink back away from the end of the stud. There is salt and water intrusion into it, and it starts to rust. It's generally very easy to tell when they start to rust. And this is something that we recommend replacing when you start seeing that. This is another lifeline stud. You'll see that it has that same crevice corrosion that we talked about earlier. This would be something that we would deem a failure and would get replaced. The next place you want to look on your lifelines is up around your welds. Welds are generally the first place to start rusting. They don't get the same treatment. They've been heated up more than the rest of the metal. They're more susceptible to rusting. And you can see here that it's probably had some stress up there. So we have some stress cracks with some crevice corrosion, and it's all around that area that's been welded. So that's something that you want to look for. We see lifeline loops fail as often as we see lifelines fail. Overload. This one happens a lot. This particular boat hit a bridge. It is deck stepped. They managed to lose the pin on their forestay, but luckily had a halyard, which had some elasticity in it to take the load and hold the rig up. And it's also surprisingly being supported by their boom with their rigid boom vang on their Dodger. And that's kind of also working to help hold it up. This is a stay that failed due to overload. You can see that all the wires have just splintered apart and broken off at different spots. This is what happens to a toggle when it's been overloaded. So the pin's actually pulled up in the other direction where you can see it still fits, but you can see this kind of half moon shape added to the bottom where this pin has pulled down and started elongating the toggle in a way that it shouldn't be. This is often caused by either being in a situation where you have too much pressure on your stay, maybe overloading your sails or halyards. It can also be caused a lot by having a hydraulic backstay adjuster that you maybe pump on a little too much. Although these are great tools to use, you do have to use them carefully. So now I want to talk a little bit about upgrades and add-ons that we do, particularly for our blue water sailboats that we do a lot of in our shop. The first one is Steve's favorite. This is a top-down furler. This is a video and I don't know how well it's going to play for you, but I am going to play it so you can see it. I'm actually going to skip to the next video, which is of the furler furling in, because I think it's much more interesting to watch than the one unloading. So I apologize in advance if this doesn't work for some of you, but I'm going to play it anyway. So this particular one is a Banmar furler. So it is furling on an electric winch. You can see it backwind a little bit here, and our video should pan up. And you can see it just starting to wrap around the top of the sail and the top of the furler, and it rolls from the top of the furler down. This is a great, safe way to use a spinnaker while you're out sailing. It allows you to do it without having to have a person up on the deck to help douse the sail. It's a relatively quick way to roll it up. I know this doesn't seem hugely quick, but trust me, on a boat this size, it takes just as long to take it down with people, and you need 4 people's hands to help you get the sail down. Where this way you just wrap it up nice and tight and it's stored. I know for a lot of Code Zero sails that a lot of people are getting sun cover put on it, so you can actually leave this up and in the sun. And it's a relatively easy installation and build to add onto your boat.
All done.
The next thing we always recommend, it's a super easy thing, I'm sure you all have them, is a whisker pole. And as long as you are using them safely and correctly, they will help your sailing a lot by holding your jib out. By this example here, you can see that they're sailing in a downwind direction. And this allows you to hold your jib out and sail in a nice wing on wing position, helping you to even get to a downwind. We would recommend having jibe preventers set in case you get any wind shifts or someone bumps your wheel and sends you off in a direction that you're not supposed to go. Boom brakes. There's a couple different styles. This is our favorite style, which is the Wishard. You can add tension to it really easily by looping it through itself. It's a very simple and easy design. You want it on your boom approximately where your bang is, or just after where your bang is. and you can hook it up. Generally, you have a midship cleat in about the same place where you want it on each side of the boat, where you can tie it off to on each side. We'll either run them as a fixed line that you can adjust through the ferrules to work as a brake, or we will run it back with a clutch to the cockpit. So if you wanted to quickly let off the boom brake, you can just simply open the clutch and it would go slack. This is another style of boom brake. This one has a knob in the bottom. That is this black piece here at the bottom that you can use to either turn the friction on or off. And this one is rigged up in one of my favorite ways, where you actually run this green line, doesn't have to be green, but it is in the picture, back to the cockpit. And from the cockpit, you can actually put it on a winch to put more tension on or pull less tension off of your boom brake to use it when you may or may not need it. That way it's kind of always pre-rigged, but it's not really running. And then when you need your boom brake to work for you, you can pull that tension on and adjust the tension from there. A cutter stay. Now, obviously, this isn't an add-on that you can add on to any boats, but it is nice to get a cutter stay onto your boat or stay sail. Something to give you a little more sail area forward. You can balance the boat with it. You can use it as a storm jib. There's endless options. I know that everyone who's added one to their boat has loved it. With that, if you have a cutter stay or a staysail rig, we suggest that you have runners for it. An offshore runner in particular wants to be at about the same place that that stay is on the boat. And you'll see in this diagram, we'd have that stay here, and it comes back to a runner, which has a block, a dead end point on the boat, and then that would come down to another block, which would lead to a winch. That way you can actually put some real tension on it, creating a flat sail. I'm sure, as we all learned in sailing school or wherever we learned to sail, you know, as the wind builds, you need to start spilling wind from your sails in order to keep the boat flat and balanced. You do that by making your sail flat. The flatter your sail, the less overpowered you're going to be. To make your sail flat, you would use an outhaul on a boom. So for this, we're going to actually pull the front edge, the luff of your sail, tighter by tightening the stay that it's on, so it can work to its best strength and spill the air. Another thing we do a lot of installations on are hydrovanes. Hydrovanes are a huge topic, as all are all of these, but a hydrovane is particularly nice self-steerage device because it has an independent rudder. So if you were to have a rudder failure, you could have your hydrovane rudder and plug that in. And although it's not big, it would still give you some steerage. The great thing about a hydrovane is also needs no power to it. It is strictly used by the power of the wind. So you're not draining your solar or your batteries or having to run your engine to charge anything. It is self-sufficient. So what you do with your hydrovane is you get your boat balanced and you let it kind of sail itself. There's a couple different adjustments for the way the wind works, but they're really, really nice to use. One of our favorite things to do on a boat is to add an arch. An arch gives you endless options to put things on your boat that you wouldn't have room for. This particular arch has wind generators on it. It has solar on it. It has dinghy davits on it. We often put seats on the back of our arches. We can put life racks on the back of our arches. We've put radars and all the other antennas that you want up there. It's a great place to put stuff, especially if you're going offshore. And we've had people lose rigs, not to our fault. You know, they weren't our clients before they lost their rigs. And if you lose a rig offshore, you're going to lose your sat phone. Often you're going to lose, you might not lose your sat phone, but you'll lose your SSB or you'll lose your VHF connection, and you can have spare antennas run off of your arch in case you were to lose your rig. They could still end up damaged, but it is a backup plan and it's something a little bit higher than just sitting on your stern rail. Leisure frill boom furlers. The leisure frill is my particular favorite. We do the Schaefer as well, but I think the leisure frill is a little more hardily built. The nice thing about a leisure frill for a mainsail furler, now, you know, there's nothing wrong with slab reefing. It is definitely the safest way to go. But the nice thing about a leisure frill is it lets you reef at any point. You can furl it to any direction. So instead of tightening your outhaul, you furl your sail a little bit and that flattens your sail. Let's say you're not at quite the point of windage where you would start your first reef on a normal sail, but you're feeling slightly overpowered. You can take a wrap or two up and just furl it to the first batten, and it kind of gives you an unlimited reefing ability. And for the most part, I would say that they're pretty user-friendly. It takes a little bit of technical skill to start learning how to use them, but once you get comfortable with them, they work really, really well and are really efficient. So that's it for me. I'd like to open the floor up to any questions that you guys might have. You can either turn your mic on and ask or put something up in the chat box, however it best works for you. Thanks, Matt. Appreciate it. Any questions? Anything else anyone wants to talk about? No, we do not have a location in Florida. We are in Maryland only. If it's really important, we will fly to you. Using zip ties versus safety wire. That's an interesting question. So I think you can use zip ties or wires pretty interchangeably as long as you're checking them. Zip ties do break down in the sun. So if you were to put like a spinnaker block on the top of your rig, I would probably use wire as opposed to a zip tie, because you're probably not going up to the top of your rig, you know, every 6 months to check on a zip tie. But if you want to use a zip tie for your jib furler to keep that snap shackle closed, that's a great application for it. What's your preferred method of bending cotter pins? Okay, a lot of people bend cotter pins all the way around, making what we call bull's horns or ram's horns, and they spin around. That is not the preference. It is very hard to get them straight, and you're actually fatiguing the wire more by doing that. Standard military operation says to spend it to about 15 degrees, which is going to be about this much. Now, inside of turnbuckles, we generally open them up completely flat so they can't snag on anything. But other than that, you want it about 15 to maybe 30 degrees open. What are the recommendations for lubricating different parts of rigging? That is a very loaded question because there are about 1,000 different things. For sails, we always recommend McLube because it's quick, it's easy, it comes in a spray can. For most of your furler bearings, you're just going to use the same grease that you would use in your winch. It's all kind of the same stuff. And then for anything with ball bearings that isn't supposed to be grease packed, 1 drop or a 3-in-1 oil. Wire or Dyneema for safety lines. If by safety lines you mean lifelines, I recommend wire because Dyneema can chafe. If you rather mean safety line, as in when you're climbing a rig and want to put a line around something to hold yourself up, I recommend Dyneema because it is flexible and easy to wrap around something.
Right. Any other questions? And I agree. I love the visuals. Those were really helpful just to, you know, and there were of everything just to see, you know, all the things that you were describing. That was fantastic.
Yeah, I am very much a visual learner myself. So I think being able to see what we see, and sometimes, you know, most of the time it's not going to look this bad. These are kind of the worst case scenarios, but these are what happen. A couple of them show you just kind of the starting stuff that we look for. So the more you know, the more you can see, the better you can take care of your boat.
Absolutely. So all the captains out there who are registered for the Caribbean Rally, if you haven't already, get your inspection done. Find all the flaws.
All right. Well, thanks everybody for listening. I appreciate getting to spend some time with you. I know a couple of you are already on our schedules for a rigging inspection, so I will see you very soon.
Looks like there might be one more question. It says, what do you think of dye testing?
Okay. So if you have rod rigging, dye testing is a great thing to do. It's not always applicable in everywhere, but if we pull chain plates, we'll often do a dye test. And if we have rod rigging, we'll often do a dye test. So what that does is it shows you if there are any cracks on the surface that you might not be able to see with your eye. So you clean the rust off of the surface and then you put a penetrating colored oil on it, wipe it off, and then put a white chalk over it. And where that penetrating oil has seeped into the cracks will get sucked out by the chalk. So it's a really great way to be able to see what's going on when you might not be able to see it with your naked eye. What do you think of plastic covering on shrouds? Terrible, absolutely terrible. Take it off, get rid of it. Don't have plastic on your shrouds. So like we talked about with chain plates and them getting trapped with water moisture next to it, you're doing the same thing with the plastic covers on your shrouds. If you have them, if they really, really help you keep your jib sheets from getting caught, I want you to at least once a day, move the whole thing up, wipe your shroud down with a cloth, and you can pull the plastic cover back down. But if you move those up, you will see 99% of the time that there is dirt and mud and water full in those, and they seal right down to the stud, and you get so much water in there, and it is so bad for your wires.
All right, looks like that might be it.
All right.
Thank you. Again, that was great information, and the recording will be available. I'll probably send it out in the next day or two. So for all, if anybody wants to watch and, you know, get the information that they might have missed. So it'll be available soon. Thank you, Anna.
All right. Thank you. Have a great night, guys.
Take care.
All right. Bye-bye.